Hello everyone, welcome to Explore Hop. So for this example, we're told that in a population of 100 people, there are 60 females and 40 males. 10 females and 15 males are colorblind. For part A, we want to find the probability of a person being colorblind given that they are female. For part B, we want to find the probability of a person being colorblind or female. So let's start by defining the following events. Let's first start by letting event M be equal to the event where a randomly selected person is male. So M is going to be equal to the event where a person is male. Now, let's let event F be equal to the event where a randomly selected person is female. So event F is going to be equal to the event where person is female. Let's let event C be the event where a person is colorblind. So C is going to be equal to the event where a person is colorblind. Now, let's find the probability of some of the events we just defined above. So the probability of event M, which is the probability of a person being male, is going to be equal to 40 over 100. Since we have 40 males in total, and the population is 100 people. Likewise, the probability of event F, which is the probability of a person being female, is going to be equal to 60 over 100. Since we have 60 females and the population is 100. We can also see that the probability of event C, which is the probability of a person being colorblind, is equal to 10 plus 15 over 100, which is 25 over 100. Since there are a total of 25 colorblind people. From the question, we can also find the probability of the intersection of event F and C. And from the question, we see that this is equal to 10 over 100. Because there are 10 people that are female and are also colorblind. Likewise, the probability of the intersection of event M in C is equal to 15 over 100. Since 15 people are male and colorblind. Now, to find the probability of a person being colorblind given that they are female, we need to find the probability of event C given F, and we can do that by using this formula. So the probability of the intersection of event F and C is equal to the probability of event C given event F times the probability of event F. And from here, we just solve for the probability of C given F. So the probability of event C given F, which is the probability of a person being colorblind given that they are female, is equal to the probability of the intersection of event F and C divided by the probability of event F. And so this is just equal to, well, we know that the probability of the intersection of event F and C is equal to 10 over 100. So this is just equal to 10 over 100 divided by the probability of event F, which is 60 over 100. And this, of course, is just equal to 10 over 60, which is equal to 1 over 6. So that gives us the probability of event C given event F. So that gives us the probability of a person being colorblind given that they are female. Now let's move on to part B. So for part B, we now want to find the probability of a person being colorblind or female. So we want to find the probability of the union of event F and C. And this is just equal to the probability of event F plus the probability of event C minus the probability of the intersection of event F and C. And this is just equal to the probability of event F, which is equal to 60 over 100, plus the probability of event C, which is equal to 25 over 100, minus the probability of the intersection of event F and C, which is just equal to 10 over 100. And this is equal to 75 over 100, which is equal to 3 over 4. So this gives us the probability of a person being colorblind or female. And that's it for this example. Thank you for joining us. See you in the next lesson.